Good day, guys. My name is Albert, and this is my channel, Einbert Electric. Today, I will discuss about the kinds of branch circuit loads and panel boards. It is important that before we start the more calculations on the different types or kinds of branch circuit loads, it is important that we understand each kind of loads. And also, I will discuss briefly on the kinds of panel boards. This is part of my DIM lecture series, which is Design, Installation, and Maintenance, as part of Electrical Design Fundamentals. First, we will discuss what is a panel board. This is a panel board, as you can see, and this is a part of a panel board which is showing the power bus bars where the circuit breakers or the overcurrent protection devices are installed. So what is the meaning of the panel board? According to NEC, or National Electrical Code, a single panel or a group of panel units designed for assembly in the form of a single panel, including buses and automatic overcurrent devices, and equipped with or without switches for the control of light, heat, or power circuits, designed to be placed in a cabinet or cutout box placed in or against a wall, partition, or other support, and accessible only from the front. So this is the panel board. So basically, it has a power buses, and it is there where our branches overcurrent devices are installed. And it is mentioned that it is accessible only from the front. So we have a cover here in the real panel board. There is a cover in front where it is the only way of access. Now let's go to the components of this panel board. The first and foremost is the main overcurrent protection device. What is this? This is here. This is the main overcurrent protective device. This is where the main bus bar is connected. And also we have the branch overcurrent protection devices. This is where all of them is installed in the buses, and the buses have a branch connections. This is where all circuit breakers, or in some case fuses, are installed. There are two types of circuit breakers according to installation. We have the plug-on, we have the bolt-on, and the plug-in type. The bolt-on type is being screwed in the bus, while the plug-in type is just being pushed. So there is a pin on the bus where the circuit breaker contacts opens and latch. That is a plug-in type. Now this is the power bus bars. This is where power is connected. So from the main overcurrent protection device, it is going to the bus bars. Also, we have the neutral bus bar. There is a bus bar here dedicated for neutral connections. Later, further, we will discuss about neutral and from where it is taken from. Also, there is a ground bus bar. There is a separate bus bar in the control panel where all grounding cables, or shall we say all equipment grounding conductors, are connected. This is for protection of the equipment and also of personnel. And of course, there is the panel board housing where this assembly of circuit breakers and bus bars is being installed, and it is protected by a cover. Now let us go to the kinds of branch circuit loads. The first type of branch circuit loads are pure resistance loads. Pure resistance loads are generally resistors, and this includes, for example, water heaters. Water heaters is made up of coil with resistance, and when the current flows, it will heat up and eventually heating the water. Incandescent lamp is basically also resistance. When the current flows through its filaments, it is heating the filament, and then it will produce a glow because of heat. Rice cookers, same principle in water heater. There is a coil below our cooking pan. When the current flows to that resistance of the coils, it will heat up, and then it will boil our rice and it will cook it. Electric iron, very basic. It is also a coil with resistance, and the heating, they just put some thermostats to make it on and off, so it will not heat up more and more, so we can control the heating. And oven, of course, there is a heating element inside, also controlled by thermostats through our knobs, so we can adjust the temperature inside this oven. So all these are examples of resistance loads. And also we have the furnace. As some of us know, furnace, this is where we melt some metals. We put some metals inside and it is melting. This is also basically made up of resistances, and it is produced heating. In my first episode, I discussed about water heaters. I used a branch circuit as a water heater. That was in my first lecture video episode. If you want to go back to my first lecture, you can check it out, because that is very important and that is very basic. That is a general calculation of a branch circuit calculations. The next type of branch circuit load is capacitance loads. Of course, this is made of capacitors, and for example, we have capacitor banks. If you are an electrical engineering student or an electrical engineer, capacitor banks is installed in loads where there is a requirement to improve the power factor of the load. So it will also one of the branch circuit loads. Next are pure inductance loads. Motors, for example, they are inductance loads. They are made of windings, magnetic wire, and this includes fans and ventilators. Of course, they are rotating equipments, and they are made of motors and magnetic wires. Pumps are basically driven by motors, and different from a mere simple motor, we have compressors. This includes air conditioning equipment. In an air conditioning equipment, we have what we call as uh, hermetic refrigerant compressor motor. This is hermetic because it is enclosed and it is cooled by a refrigerant. It is using refrigerant to produce the pressure. And of course, transformers are made of coils, winding of coils, magnetic wires, and also some loads we have like coils and solenoids, which is made up of fine coils of wire that produces as an electromagnet and then uh, magnetizes or pulls a what we call armature and then releases by spring. They are called solenoids. And of course, this is a common load for an electrical branch circuit: lighting loads. In lighting loads, we have CFL lamps, or what we call as compact fluorescent lamps. These are actually fluorescent lamps, but they are made compact, become made smaller, but they produce the same or equivalent lumens or intensity of light. Of course, the classic fluorescent lamps, and then LED lamps. We have LED or light emitting diode lamps. This is the most popular nowadays, that is used in our buildings, offices, etc. And of course, some special lamps like warning lamps. This is used for signal lighting. For example, in our chimneys, we call it aircraft warning lamps. This is blinking, especially in the night when the sun sets down. It started to blink, and usually it is color red, just to give signal to aircrafts that there are some part of buildings or chimneys is up in the air. And street lights, of course, street lights are lighting loads, and this is common in our roads, highways, alleys, in our toll gates, and all other roads and bridges. And also floodlights. This is mostly used in buildings, high-rise buildings, and big buildings like cultural centers and other buildings that needs to be lighted during the night and for beautification purpose. we are using floodlights. And we have also receptacle or convenience outlet loads. Outlets are loads that is not yet used. However, whenever we uh, came and we want to plug some equipment or appliances, we are using this. For example, we have some single receptacle. Others are duplex receptacles or CO. CO means convenience outlet. And power sockets in some industries, in manufacturing plants, they use power sockets because it is used for plugging like motors and other heavy rotating equipment. Industrial sockets, similar. It is different from receptacles. This is used mostly for motors and other industrial equipments. Special purpose outlets or SPO. This is mostly used in our homes and houses, buildings, offices, which is purposely uh, for special equipments which we want to use. For example, window AC. Window AC, we can consider it as a special purpose outlet because it is different from a normal receptacle. You cannot plug any equipment in this special purpose outlet. It is dedicated for that load only. And we have combination loads. As we go back, we have heaters, we have motors or compressor motors, like in the aircon equipment, lighting, or receptacle or outlets. All of these, if combined together in one circuit, this is called a combination branch circuit, and it is possible. So these kinds of branch circuit loads have different way of calculation. So now, just for familiarization, I am discussing this so that we will know what are these different loads. Then later I will discuss how each of this type is calculated. So this is the panel board single line diagram. As you can see, this is the main overcurrent protection device and the branch circuit protection devices. The main always is on the top. In the diagram, it is always on the top and it is feeding the branch circuits. Also, it is protecting all of these branch circuits. And branch overcurrent protection device are protection devices for each branch circuits. Now, let us briefly discuss the kinds of panel board. Lighting panel board. This is a panel board that feeds only all lighting branch circuits. So if you are connecting only lighting in this branch circuit, it will be called a lighting panel board. Power panel board. It will be called a power panel board if it feeds motor branch circuits of more than 6 motors. So if this panel is feeding only motors and the motor is more than 6, it shall be called a power panel board. Emergency panel board. As the name implies, this is a panel board that feeds emergency branch circuits. For example, you are feeding emergency light and other emergency equipments. It will be called emergency panel board. And now distribution panel board, or DB, commonly called DB, distribution board. You will call it a distribution panel board if it feeds, for example, lighting, and also including convenience outlets or receptacles, and also motors. So if all of these together are connected in this panel board, it will be called a distribution panel board, or DB. So this is the end of my brief presentation. Now we are ready for the calculation of our different types of branch circuits, which I will prepare. And please follow my channel, Einbert Electric. Just click like and click the notification bell and select all, so that you will not miss any of my succeeding video lectures. Thank you for listening and watching.